Or if you're a biology student, you think of those little fur things that live underground. Okay, so 1 mole is equal to 6.02 times 10 to the 23rd particles. Now, anything that you know about dozen in everyday life, mole is going to be the same. It's a general term. I can talk about 1 mole of atoms. And I have 6.02 times 10 to the 23rd. Need to know this number. Okay? 6.02 times 10 to the 23rd. It's a huge number. Okay, if I did not lose count, it's that. You can see a very good argument why we go into scientific notation. Okay, the point is, and let me just talk it through instead of writing each one. I can use that term mole on anything. I can say a mole of atoms, and I have 6.02 times 10 to the 23rd. I can say I've got a mole of molecules, and I have 6.02 times 10 to the 23rd molecules. I have a mole of electrons, and we have, how many, don't look up there. We have a mole of electrons, and it is? Very good. Sounds kind of like church. So 6.02 times 10 to the 23rd. Know that number. So it's a general term, just like dozen is. The other thing is, I can talk here, general, atoms, molecules, electrons, anything. It's just it's such a huge number, it's not applicable for everyday life, except when you're talking like molecules of the water in here. Okay, the other thing is that we can use multiples of it. I can say I have 2 moles today, and I would multiply this by 2. Now this is not good form. It's not good form because I just did this in my head, and I can do it in my head this way, but then I would clean it up. It'd be this. So that'd be 2 moles, right? Or I can talk about a half a mole. Go up there, take half of that, and I've got 3.01 times 10 to the 23rd particles. Okay, everybody sold on that idea? It's not going to be some weird thing. It's just like the dozen. It's just we use it in chemistry class. It's just a big package of the stuff. Okay, now, let me write a super important sentence. And this is 4 elements. If we take the atomic weight of an element and express it in grams, this will be 1 mole of atoms, or 6.02 times 10 to the 23rd atoms. Okay, this one's a biggie. It's been found that, actually they work with carbon first, I think. Okay, if we look up there at carbon, look up here at carbon, and let me just use the nearest whole number for the time being. The atomic mass, or atomic weight, is 12 grams. Okay, well, 12, actually, let me backtrack just a little bit. It's 12, and in chapter 1, I would have been saying it's 12 AMUs, atomic mass units. Remember that relative business? Everything was based on carbon. Okay, well, hey, atomic mass units, we don't have balances and stuff that weigh out in atomic mass units, so get the idea. We're going to be practical. Let's take 12 grams of carbon. you know, enough to get her hands on and see. Remember this ring weighed about how much? 7 grams, so about double that in grams of carbon. Okay, now you could visualize an experiment. You have this 12 grams of carbon, and you start counting atoms. If you had a really good microscope, you know, or electron microscope to see that. If you started counting, and you had a few lifetimes to do it, that you would find if you had 12 grams of carbon, you would have 6.02 times 10 to the 23rd atoms of that carbon. Okay, now let's go through 2 and 3 of these. Okay, so taking this basic idea, 12 grams of carbon is 1 mole of carbon, or 6.02 times 10 to the 23rd atoms of carbon. Okay? Now, let's take magnesium. Look up there on the magnesium. 24. So, if I want a mole of magnesium, how much do I have to weigh out? 24 grams. Okay. Now, do you think, here's 1 atom of carbon, and it weighs 12. Here's 1 atom of magnesium, and it weighs 24. Okay, each one weighs twice as much. So if I want to have the same number of atoms, 6.02 times 10 to the 24, I can have twice as many grams of the magnesium. Now, what if we want to do hydrogen? I want a mole of hydrogen. So how many grams should I weigh out? 1. If I want to talk atoms, see, it's not till we get to molecules we say diatomic for this. So 1 gram of hydrogen is 1 mole of hydrogen, or this many atoms of hydrogen. So all you have to do, the basic idea is, you got a mole. I want a mole. Tell me what the atomic weight is, and that is a mole, and you know how many atoms it is. Okay, now look up there at carbon. Okay, 1 mole is how many grams of carbon? 12. Hey, today, I want 2 moles of carbon. 24. I want 3 moles of carbon. 36 grams. Okay? Now, what if I say I have 48 grams of carbon? How many moles would that be? 4. Okay, so here's one of the most important things you learn in your chemical career. And this will haunt you forever. As long as you take chemistry, you're going to hear this idea. You've got to get really good at going grams to moles and back again. Now, you just did it in your heads there with carbon. Did you hear what I was saying? I'd say, I want 2 moles. And you told me that's 24 grams. You were making that, but those are easy numbers to work with. Let me give you a diagram, which will always work for you for elements. You have grams. You have grams, and you want to go to moles. Or you have moles, and you want to go back to grams. Or, let's extend that. Sometimes, not too often, but sometimes you want to go all the way to atoms. Sometimes you want to go from moles to atoms, or if you have atoms, you can go back to mole. And of course, if you have grams, but you would like to really know number of atoms, you got to go grams to moles to atoms. This little diagram will take you wherever you need. Okay, now, what will take us there? If we have grams, and I want to know moles, for instance, I have 48 grams of carbon. How many moles do I have? 4. What did you do in your head, Bruce?
Divide them.
Yeah, so if you want to go here to here, this direction, you divide by the atomic weight. That's just what he did.
Can you explain that again, please?
Okay, what I said to Bruce, I got 48 grams of carbon. How many moles is that? And he says 4. Now, I asked him, what did you do in your head to get 4? He took my 48, he divided by 12, the atomic weight. See, every time you divide it up into packets of 12 grams, you've got a mole. So if you want to go here to here, you divide by the atomic weight. Okay, I have 3 moles. I want to go back to grams for carbon. 3 moles of carbon. How many moles, or what did I say? 3 moles of it. How many grams of it? 36. What did you do, Nina, in your head? What math?
I multiplied 12 times 3.
See, you just instinctively were doing that. But when the numbers get weird on you, you know, instead of even, it's going to be harder. So grams to moles. Okay, divide by atomic weight and you get there. If you're here and you want to come back, you multiply by the atomic weight. Super important. Okay, now what if we're at moles? Every time I have a mole, I have how many? Give me that number. Don't, it's not up. Oh, yes it is. Don't look over there. Here, look this way. Okay, I want to hear the number.
6.02 times 10 to the 23rd.
Good. Need to know. That's one of those repeated 5 times and it's yours for life. It's also referred to as Avogadro's number to honor, I think that's an Italian physicist by that name, so Avogadro. Everybody's got Avogadro's number. So 6.02 times 10 to the 23rd. Every time you have a mole, you have that many, but if I have 2 moles, then I would do what? I'd multiply. And if I'm out here and I want to come back, well then I divide. Okay? Now, let's take, we've got about 4 minutes left by that clock. Here's problem 2-4.